Hello, Mario! In this video I'm just going to explain a fairly simple double run levelling scenario where we start at a level with a known height, move or run out to a new mark, establish a level on that, and then come back to the original. So it's a fairly typical in and out double run levelling run, and it's going to be one that I'm going to get students to do, and includes some intermediate shots and one inverted shot. So previously I have set up an alloy plug by the container where we store our survey gear. I've also established alloy plugs on a mowing strip to the west of the container, just outside the end doors of G block coming out of the student street. And I've called that one AP Mow because it's in a mowing strip. I've also established another alloy plug to the east of the container on top of a curb adjacent to a speed hump, which I've called AP Hump. Now if you set your level up at the right place in the first initial setup, you are able to see each of these marks from one position. And so what we're going to do is use AP container. I've given that a assumed level of 65.432. So assumed level of 65.432. And then we're going to establish levels for AP Mow, AP Hump, container roof, and AP Net B. And this is an alloy plug that I'm going to put in on Monday morning over by the Netball Waikato Centre, just atop of a bit of a curb there, and it's a bit of a distance away from AP container. So the situation is that what I want you to do is to set up and take a back sight to AP container, and then pick up the three intermediate sites at that same setup: AP Mow, AP Hump, and container roof, where we will hold the staff upside down to get a level of a part of the container roof. And then we'll do a foresight to CP1 or change point 1, where you can either use a levelling plate or a screwdriver or a peg to hold the level. Then you will move the level and set that up and take a back sight to CP1, put in another change point and a foresight to that change point CP2. And then you will move the level again, back sight CP2 and foresight to AP Net B. And that's one run out to AP Net B. All the time as you go, you should be recording the rise and fall, and that should give you a level at a raw level at AP Net B. Then we will come back, and it's pretty much the reverse procedure, although the change points won't necessarily be the same. You could use different ones, and that's why I've given them as different levels there. They're approximately the same but different. So each time the change point is pulled up and put down in a new place. So I have labelled them CP2 and CP1 and reversed them, but they are actually different points, and that may be something that I will live to regret, that I perhaps should have given them different names. But anyway, that's been done now, and we're going to move through. And then once again we'll get back to in the vicinity of the container, and we will check the redo the intermediate shots to the container roof, AP hump, AP mow, and then finally foresight back onto AP container. So that's sort of the scenario. Let's have a look at what we've got here. So first of all, you'll note that every sighting to a particular mark that is labelled down here is on the same row. So the first thing we do is set up the level. We take a back sight to AP container, and usually when we're levelling, the first sight we take is a back sight to a point with a known height on it, or an assumed height in this case. So we're taking that AP container. We then go through and take our intermediate shots here to AP mow, AP hump, container roof, and then we take a foresight to change point 1. And that is the first levelling setup. So we're moving from left to right, one shot. Then we obviously hold the change point and we move the level to a new position between CP1 and CP2. And so we take a back sight to CP1. So that's how we get the 2. So remember, the foresight always comes before the back sight. Then we take a foresight to CP2, which is another change point where we can use the levelling plate, a screwdriver or a peg. Then we move the level again, take a back sight to CP2 and a foresight to AP net B. And that establishes us there, AP net B. Then we take a back sight to AP net B, foresight to CP2, back sight CP1, back sight CP2, foresight CP1, back sight CP1, intermediate shot to container roof, hump and AP mow, and then a foresight back onto where we started, AP container. Now, to work out the rise and fall is fairly simple, really. You just always take the one on the lower row away from the one on the row above. So it's that back sight there, 1.856 minus 1.958. Now, if that comes out as a negative, and I've actually shown them as negatives here, although that is technically not necessary, I have shown them as that there, and that comes out as a fall. Okay, so that back sight minus foresight, and then we go to the next one here, and it's intermediate minus intermediate, and that's a rise because there's it comes out positive. And then here we show the inverted shot as negative. Okay, or here it's we show the inverted shot as negative, so it's 1.874 minus 0.873, which gives us a rise of 2.747. Then it's negative 0.873 minus 1.554, and again that's negative, and so on as we go down through like this, always from here to here, here to here, back sight minus foresight, back sight minus foresight, and then back sight minus intermediate, intermediate minus intermediate, intermediate minus intermediate, intermediate minus foresight. And that gives us, if it's positive, a rise, and if it's negative, a fall. Then as we go, we just add the levels, So from there, we add that, whatever, with the right sign. So it's 6 that plus negative 0.102, and then it's plus 0.084 plus 2.747. So that one there, plus negative 2.437 plus 0.218 minus plus negative 0.2 plus 2.225 plus negative 2.68, and so on, all the way through here until we come down. Now we know that if we started at a level of 65.4 65.432, we should end up at a level of 65.435. But as it turns out, we don't. We've got a 3 millimetre misclose. Now, the thing with the misclose is that the intermediate shots don't really affect how it works, and it's just a matter of distributing it about. So in the first instance, I don't take into account the intermediate shot. So I'm going to take out minus 0.001 at the first sort of change point there. So that's like one set up there, so minus 0.001. I'm not going to take anything out of the next change point, nothing out of that, nothing out of that one, nothing out of that one. Now these do accumulate. So if I take, it's accumulating as we go. So I'm going to take another 0.001 out of that one there, okay, and then finally out of the very last one, 0.003 down like that. It's a little bit interesting, but you don't take in, I haven't taken into account the intermediate shots. Then what I've done is I've looked at my raw data and I've tried to balance the intermediate shots so that they come out at the same value, because you can't have two values for the same point. So for instance here, if I take minus 0.002 there and minus 0.001, that will give them the same value. And these ones here, again, minus 0.002 and minus 0.001, that will give those the same value. So I've sort of done two adjustments in there. I've done the one adjustment where I've just disregarded initially the intermediate shots and just gone through the change points to adjust out the 0.003, and that sort of accumulates as we go down. So we've got 0.002 there, 0.003 there, and then I've tried to balance out the intermediate shots so that we get the same answers all the way through. We can't have one point with two different levels because they are unique points. All right, so sort of that we'll have to see how that goes in action. The other check that you can do, so initially the check is before you leave the field, the adjustment can be done afterwards. Before you leave the field, this value here and this value here must be within 5 millimeters. If they're not, there's something wrong. Okay, and then the other checks are that if you add up the back sights and foresights, they should be equal within 5 millimeters. And if you add up the rises and falls, they should be equal within 5 millimeters, and they should actually be equal. If there's something, if these here are within 0.003 and there's something wrong in here, these things in here have been totally derived by your arithmetic and calculations. So any error in here can only be resulting from an error in arithmetic and calculation. So the actual true misclose, back sights and foresights are equal. The other things are occurring here and again in here in your arithmetic, and then we must adjust it to make everything fit. Okay, so that's just a quick explanation as to how to fill this sheet out. It has taken a little bit of time, and I'm hoping that I may be able to go through it in class, but for those of you that might want to do some review before you come to class, this is something to bear in mind. Cheers! See you!